Okay, good afternoon. Today we're going to start our discussion on modeling time series. So there are several topics in time series that we're going to look into. First, the basic forecasting, the basic modeling using Arima, and then we will go to GARCH, and then other time series, even multivariate time series. So that will cover ilang weeks yun ng discussion. Okay, so let's start first with modeling the price of stocks. In particular, kahit siguro pwede natin baguhin itong Apple stocks kasi gastado na yan. Pero sige, yan na lang, no? Usually what's modeled is yung returns. But let's start first with the prices of the asset, and then your let's say your take-home case will be to model the return. Okay, pag alam nyo naman kung paano i-model yung price, then of course you'll be able to know how to model the returns kasi halos pareho lang naman yung proseso na yon. Okay, there are certain references here which I'm suggesting that you look into. For example, this is Pennsylvania State University. This is quite a good reference. So let me open that. Okay, so this PSU, Pennsylvania State University, it's a good reference. So this is applied time series, all right? So I will require you to read in the basics. So this is a whole chapter on time series analysis. So it would be best for you to look at this reading. So objective dito. What are the important features of a time series plot? Be sure to identify and interpret an AR1 model, interpret an autocorrelation function and the partial autocorrelation function. What is a weekly stationary time series? And identify when and how to take first differences. So this one we're going to learn. Okay, that's yan yung lesson 1 niya, no? Okay, so under lesson 1 may mga say overview dito of time series characteristics. For example, if I click this, and so please read through this. Okay, important characteristics to consider. May isang example dito. Okay, so these are very instructive and very good examples so that you have an idea of what time series is, the autocorrelation function, the partial autocorrelation function, etc. Okay, and then here we will be looking at, for example, okay, may lesson 1, ang maganda dito may R code, no? For example, sa lesson 1.2 and lesson 1.3, ayan, lesson 1.3 you have a sample R code which you can follow along. So ito, kunyari, you can follow along with this one, okay, and learn from the examples. Of course, we're going to use another example. Okay, so that's a very good reference for you. And also this one, there are other references. Okay, ito naman, equations, no? Control C. Let me just show this. Is this the one? Parang hindi ito. Okay, anyway, this is an example of writing a mathematical equation for an Arima 11001101012. Quite a long model. Okay, isa na to sa pinakamahirap na na model, no? Pero ang magiging lang natin, mga simple lang. So if you know how to write a model like this, then you'll be able to write a much more simpler model. Okay, so going back here. All right, and there are other excellent resources. So just use that. Okay, so let's kindly load the packages. And if you encounter some problems, then make sure to install that package first before requiring it. So I'm going to load everything kasi naka-install na naman sa akin yan. I'll give you a few, 1 minute or a few seconds to please load the packages. So you might encounter a problem. Okay, so kung ayaw mag-load, ibig sabihin no, hindi pa siya naka-install, so paki-install na muna. You might encounter a problem with the TSM, with the TSM package. If so, kindly run this. Pag nagka-problem kayo sa TSM package. And once you're done, class, kindly chat. I'll pause recording first. Okay, so after we have loaded the packages, okay, so what we're going to study in the next few sessions are modeling time series, in particular using the Arima model. And then after that, we'll go to modeling volatility. So we're going to use the Garch model. And then after that, we go to other topics in multivariate time series. And then we go to portfolio analysis. Okay. So what's time series analysis? In time series analysis, of course, we'd like to explain a particular time series by looking at its structure. And aside from that, we would like to forecast. So aside from explaining our time series, we would like to forecast future events into the future, the time series. Okay, and a powerful model that's being used is the Box-Jenkins approach. Box-Jenkins invented or came up with the Arima process of explaining or modeling time series. So Arima stands for autoregressive. That's the AR here. I stands for integrated, and then MA stands for moving average. So autoregressive, integrated, moving average. So we're going to use this Arima, which was developed, as I mentioned a while ago, by Box-Jenkins. So in general, we can create an AR process depending on the time series, no? A time series can be created using an AR process or an MA process. If needs be, okay, if it's integrated, then we are doing what we call an Arima process, autoregressive integrated moving average. So when you say AR process, you're using the values of the time series itself. You're using its past values in order to model your time series. Okay, if it's MA, you're using the error terms. Okay, you're using the error terms in order to model your time series. Okay, so let me first explain how an AR process looks like. So this is what we call the first order autoregression model. Why first order? It's called AR1. So if you take a look at our model, so I'm writing it in LaTeX, you can find here our time series x sub t is equal to a certain constant, okay, constant delta, plus a certain function phi sub a certain coefficient phi sub 1 times x sub t minus 1 plus an error term. All right, the phi 1 here, it's like a regression model, okay? Yung phi 1 dito, ito yung coefficient natin. Okay, and then also it's called an AR1 process because you're using a log 1. Log 1 here means you are using the past value of x. So this is x sub t. You explain x sub t using its past value, log 1, which means 1 period before. Okay, if it was AR2, then you would have just like yung susunod, explain ko ano yung AR2, ano? Pag AR2, 2 lags ka na. 2 lags. And so let me just illustrate that. Suppose you have your x sub t here. Okay, and then let's say this is your most current value. Okay, so let's say 100, and then 98, and then 97. It's quite difficult to write here. 97, then another 98, 99, etc. So this is the value now. Okay, this is at time t, and then this is at time t minus 1, and time t minus 2. Okay, so when you say autoregressive, okay, auto means self. So you're using its values itself in order to explain your data. So log 1 means, okay, this one. All the log 1 value. So here you have x sub t minus 1. So this is 98, 97, 98, 99, etc. So this is your log 1, right? Because it's one period before. And then you have here your log 2, x sub t minus 2. And that's your 97, and then 98, and then 99, etc. down. So an AR1 process means that you're going to explain your x sub t using a log 1, AR1, log 1 series. Okay, so parang regression din siya, no? Ito yung independent variable natin. This will become now our independent variable. So we're going to explain our x sub t using the log 1 values. So yung before, yung one period before, etc. No? If it's log 2, then 2 periods before. So that's what we mean by x sub t minus 1, AR1, log 1. Okay, and then when we model this, there are certain assumptions here. Okay, this is your error term, no? So ano yung assumptions dito? About your error term, it should be independently and identically distributed. Okay, the mean of your error term of your residual should be 0, and the variance should be constant. So parang regression siya. No? May assumption na ganun about your residuals. This means errors, this one, are errors. Oops, bumalik. Oops. Okay. Share screen pa rin ba ako? Problema itong mouse ko. No? As I stated here, errors are independently distributed with a normal distribution that has 0 mean and constant variance. Also, sir, yes?
Excuse me po. Hindi po naka-share screen.
Sorry. Wala yung share screen ko. Okay, thank you. Also, ano pa yung properties ng error terms? Yung error term natin, dapat independent siya dun sa x sub t natin. Independence. Walang correlation dapat yung original na time series natin and the error terms. Kasi kung related sila, ibig sabihin nun, yung model natin was not able to capture that relationship. Kasi that relationship should have been incorporated in your model so that ang matitira yung residuals, yung error terms, wala nang relationship dun sa independent variable natin. Okay, and then also, number 3, the series, yung series natin, x1, x2, etc., is weakly stationary. We will explain what stationarity means. No? And also, itong phi sub 1, ano tong phi sub 1 natin ito? What's this? The absolute value of phi sub 1, which is the coefficient of for your log 1, to yung log 1 t minus 1. Dapat itong phi sub 1 na to, okay, the absolute value of that should be less than 1. Hindi siya pwedeng, yung fee sub 1 natin, hindi pwedeng maging greater than 1. Hindi siya pwedeng maging 1. It should be less than 1. Okay? So we're going to explain later on bakit less than 1 dapat yung ano natin, yung fee sub 1. So that's a very important characteristic of your AR1 process. Okay, and as I mentioned a while ago, ang AR2 process, you are regressing, you are explaining your time series based on log1 past value and log2 past value. Yung pinakita ko kanina. Yung log1, alam natin, it's a time series. It's your data from the prior period hanggang dulo. Okay? Si log2, 2 periods prior. So you're using those values in order to predict and to explain your x sub t. Diba? Ito, x sub t minus 1, this actually came from x sub t. Diba? Kaso nga lang, hindi natin sinama yung value ngayon, sinama natin from yesterday. Okay, depende kung daily yung data natin. Ito namang x sub t minus 2, may log 2 tayo. Hindi natin sinama yung value ngayon, hindi natin sinama yung value kahapon. Ang kasama natin as a regressor, yung value t minus 2. Okay, so that's why this is called autoregressive. Because you're actually using the time series itself. Log 1, which means you exclude yung value ngayon. Log 2, which means you exclude yung value ngayon at yung value kahapon. Okay, in order to explain your time series. Okay, so in general, if it's an autoregressive P of log P, so meron tayong P logs, no? So yung P log na yan, pwedeng log 3, log 4, log 5. Okay, if it's log 3, then meron tayong P sub 3. Okay, so makikita na dito yung P1, P2, P3, and then may mga attributes yung mga ano na yan, yung mga coefficient na yan. P1, P2, P3, they have certain attributes which we're going to look into. So pag ARP, ang pinakadulo niya, yung P sub P, which means there are P lags, kaya X sub T minus P. Okay? Plus your error term. Okay, so any questions about your AR process? Autoregressive process. So madali lang pag-explain, no? Autoregressive means you are using auto, di ba? Self, autobiography. You are using the values of the time series itself in order to explain your time series. Okay, and also predict your time series. Okay, is that clear, class? Yung autoregressive, please, paki-chat kung clear yung concept na yun. Auto-regressive, self, you're regressing your time series against itself. Feedback, please, kung clear yun. Please feel free to ask questions if you have any clarifications. Okay, how about the others? Tatlo pa lang yung nag-confirm, okay? All right. Sige. Thank you. Okay. Okay, then how about, sabi natin kanina, MA process, moving average. Okay, ano yung moving average? So, we have the same time series X sub T, and then we have a certain mean, average, mu, plus the error term again, and then, okay, theta 1, and then you have here, okay, may mali ako dito, dapat itong error term na to, dapat E din yan, no? Okay, so you are using past error terms. Okay, so this is the error term at time t, and then plus the error term at time t minus 1. So you're using the log 1 error term, which means so you have a model, and then you get the error terms, the residuals, and then you use that residual to model your time series. Okay, so, and then you have MA2 moving average to log2. Ganun din to class, no? So dapat this should be yung W dito dapat E siya, E. Alright? So you have here error at time t, error at time t minus 1, error at time t minus 2. Okay, so you have a certain constant plus your error term now plus T1, theta 1 times error term last period, theta 2 times error term last 2 periods. Okay, don't be intimidated by this. We'll have examples of this. No? Okay, we'll take a look at some examples of this. All right, and of course, pag MAQ, okay, log Q. Okay, so you have now theta sub Q. And this should be, sorry about that, this is your error term, error term, error term, error term. Okay? So the function is on your error term. Yun ang MA. And when you combine this, plus, so the combination of this will be, this is our error term. Combination ito, this is now your, okay, so, dapat wala na to, no? Sorry about that. So this one is now your, this is your AR1 component, no? And this is now your MA1 component, T minus 1, di ba? So the combination of that is what we call your Arima model. It's a combination of autoregressive, this is actually your autoregressive, and then this is your MA process. And of course, your Arima PQ, so log P ng AR process and log Q ng MA process. Okay. So any questions about the MA process and the Arima process? I would like to your feedback, please, kung clear ba siya, kung naintindihan natin, pag sinabi natin AR process, ano siya? AR process, autoregressive, no? So we're using past values of the series itself. MA, moving average, we're using past error terms. Okay? Past error terms. So yung combination niya, ARMA, no? Autoregressive moving average, PQ. Okay, kindly chat please if the concept is clear. Clear ba siya? Paki-yes naman or if you need some clarifications. Waiting for the others to respond. Okay, thank you. All right, then lastly, we have this ARMA PTQ. No? ARMA PDQ. All right, so ano yung ARMA PDQ? Now, the difference lies here. Meron tayong ano dito, no? We have this meron tayong D dito. Kanina, ARMA PQ lang. ARMA PQ. Ito ngayon, may Arima, may integrated dito. PDQ. Alright, so what does this mean? Later on, we will learn why this is important. Okay, suppose balikan natin, ano natin, X sub T. X sub T, kunyari 100, then 98, then 99, 97, 96. Suppose this is our time series. No? This is a time T. Ano siya, from latest. Sometimes baliktad yung arrangement. Ano? This is a time T, which means now. This is time T minus 1, time T minus 2, 3 days ago, 4 days ago, etc. Okay. Now, there will be instances when we might need to do some differencing. We'll explain later on kung bakit kailangan ng differencing. So, if there's a need for differencing, which means that we're creating now a new time series, difference dxt, let's call it dxt. Ano yung dxt? We're now going to create a new time series where we're getting the difference, no? So at time t minus 1, 100 minus 98, that's 2. Okay, and then 98 minus 99, it's negative 1. 99 minus 97, that's 2. 97 minus 96, that's 1. Okay, so we're creating now a new time series. And that time series is this one. Okay, so this is now what we're going to model, yung difference na time series. And when you see here, PDQ, yung D dito, kunyari 1, ibig sabihin nun, ito na yung minomodel natin, class. Not the original X sub T, ito na. Yung difference na time series. Okay, if this was difference 2, kunyari PDQ, where D is equal to 2, ibig sabihin 2 times tayo magdi-differencing. So that means, kunyari, let's call this D, let's say, double differencing, no? Kunyari X sub T. Then you will now have a new time series, 2 minus negative 1, 3, negative 1 minus 2, negative 3, 2 minus 1, 1, etc. No? So this is now a new time series na double na yung differencing niya. Ibig sabihin, dinifference natin minsan, ito yon, tapos dinifference natin ulit, ito yon. So our new time series now, if this was PDQ or P2Q, will now be double difference. No? Dalawang beses natin dinifference. Okay? And there are reasons why we difference our time series, which we're going to discuss as we go along. All right. Any questions so far? Clear ba tong PDQ na to? Okay. Pag nag-Arima PDQ tayo, ibig sabihin ng class, ibang time series na inaam natin, minomodel natin. Hindi na yung original. Okay, na-transform na yung time series natin. Nakuha na natin, if D here is 1, ibig sabihin, kumuha na tayong differencing. Okay, X sub T minus X sub T minus 1. So 100 minus 98, that's 2. 98 minus 99, that's negative 1. 99 minus 97, that's 2. 97 minus 96, that's 1, etc. Okay? So this is now our first difference na data. Kung mayroon pang difference, second differencing, ang gagamitin natin yung ito, yung first difference na data, i-difference ulit natin. So that's what we're going to use to get the difference of 2. All right, let me pause for a while and ask if that's clear, Kas. Paki-chat naman please kung clear yung definition ng difference dito. So difference simply means na dinifference natin data. Feedback please kung clear yung AR process, MA process, Arima process, and Arima process. Yung Arima process class, walang differencing yun. Okay, ibig sabihin, the original dataset ang ginagamit natin. We're still using the original dataset. Okay? All right, how about the others? Dalawa pa lang yung nag-clear. Thank you, Lawrence and Kuji. Okay, thank you, Hannah. Okay, I hope for the others, clear yung discussion natin. Okay, so here I created an outline. No? Outline steps in setting up in an Arima process, in Arima model PDQ or PQ depends AR process, whether it's AR process or MA process or Arima process or Arima process, pare-pareho din yung steps. No? So number one, of course, we'll just go through the process and then mas makikita natin to via an example. So number one is plot the data. Of course, tingnan natin yung data natin. Kasi by plotting the data, you will be able to check if the data is stationary. Okay, now this is very important, no? Kasi the data has to be stationary in order for us to be able to make use of the, okay, take a look at stationary. Ano ibig sabihin ng stationary? No? We'll explain that in a while. So dalawa yung levels ng stationary. Stationary in mean, and then stationary in variance. Okay? So the variable the data has to be stationary in both. Okay? If it's constant in mean and constant in variance, then it's called stationary. Stationary in mean, stationary in variance. Kapag hindi constant yung mean, ibig sabihin may trend yung data, or hindi stationary yung variance, ibig sabihin lumalaki yung variance over time or lumiliit siya over time, then hindi stationary yung data natin. Okay? If the data is not stationary, then we cannot use Arima. Hindi tayo pwedeng, di ba, ang nag-develop nito si Box Jenkins, 1976. Dinevelop nila to. Of course, nagkaroon ng improvement over time, but when they developed it for the first time, 1976 yan, okay, and the majority, yung pinaka main points ng Box Jenkins, it has remained, no? Which means it has withstood the test of time. So napaka-powerful na model to. And we'd like to use this to model our stock returns and the log returns of our stocks. Okay. So paano kung hindi stationary? Then kailangan mag-transform. Kasi kung hindi stationary, class, then you cannot use this. You cannot use the Box Jenkins approach. Okay. So, ano ibig sabihin ng stationary? Dalawang klase, no? Stationary in mean and stationary in variance. Okay, I think let's have an example, no? Nilagay ko ba dito yung ano? Okay, and sorry about that. Kung hindi ko nalagay yung site, clear ko muna to. Did I put here the site? Okay, tingnan natin to, class, ito. Yung nasa 130. I think I placed here yung plot ng stationary. Okay. Take a look at this one. Stationarity of a time series model. Okay, this is an example of a stationary time series. Why is this stationary? Take a look at the mean. Di ba yung mean, constant across time siya. Ito yung average niya. In other words, wala siyang trend. Hindi siya umaakit na ganun, no? Kasi if your time series is going up like this, then it means, class, that hindi constant yung mean yan. If you take a look, let's say, across this portion, the mean niya, somewhat along, ito yung average niya. Pagdating mo dito, class, dito sa portion ng time series na to, ang average siya mga ganito. Ito yung average niya. So, what's happening? The average is not constant over time. It's actually increasing. May trend siya. So kapag ang time series has a trend, then hindi stationary yun. Okay? So this time series is stationary in mean. And not only in mean, it's also stationary in variance. Bakit, class? Kasi yung variation ng data natin, okay, it's constant across time. Hindi siya ganito, no? If our data is like this, okay, so kunyari ganyan yung data natin. Okay. Now, probably, this data is stationary in mean. Bakit? Wala naman siyang trend eh. Actually, the mean of the data is constant. Ang nagbabago sa kanya yung variance. Kasi, meron siyang tinatawag na fanning out. Okay? At this level, ang variance ito. At this level, ang laki na ng variance. Ito na. At this level, ang variance natin, ito lang. Okay, so while this data, okay, itong data natin na to, constant in mean, constant in variance. So okay yan, stationary. As I was saying a while ago, kung tumataas yung data natin, then that means hindi siya stationary in mean. Okay, it can be stationary in variance, but not stationary in mean. If our data is like this, okay, ibig sabihin nun, it can be stationary in mean kasi wala naman siyang trend kahit na tumataas yung ano niya, no, yung variance niya. If you take a look the mean, pareho pa rin across time. The mean is still constant. Pero yung variance niya, okay, malaki. It's increasing over time. Alright, so that's why, as I said, dapat yung stationarity, dapat in two counts yan. Stationary in mean, at saka stationary in variance. Okay, so let's take a look at this. Ito, class, ito, it looks like mukha siyang stationary in terms of variance. Parang stationary naman siya, no? Okay, wala masyadong yung fanning out except at this level lang. Okay, pero at this level parang ano pa rin siya, no? Okay, but this is not stationary in mean. Kasi may trend siyang pababa. In fact, dito mas lumaki yung trend pababa. Tapos tumaas dito. So hindi constant yung mean niya. Okay, so this is not stationary in mean. Although pwede, it could be stationary in variance. Except at this points, no? Kasi dito yung variance mo pag ganito lang Tapos dito bigla naging pa ganyan. So kasi yung data natin. Tapos dito naman naging pataas na. Okay? So hindi constant yung variance natin. Okay, hindi constant yung mean, hindi constant yung variance. All right. So how about this one? Okay, yun lang yung example niya, no? Okay, may mga iba pang example, no? Siguro tingnan natin, ha? Just to okay. Non-stationary. That's non-stationary, stationary in mean and variance. See if we can find an example here. With non-stationary data, image na lang. Okay, mas madali makahanap dito. Yan, class, dito. Okay, take a look at this. Ito, visit natin to. Okay? So this, yung image, ano na to? This is stationary in mean, stationary in variance. Okay, this is non-stationary in mean, time-dependent siya. Across time, there's a trend. Okay? Ito naman, okay, non-stationary, mukhang stationary in mean siya. Kasi yung average mo, over time, pareho pa rin Although may mga high points dito, may mga low points, but the average will still be almost the same. Pero hindi siya stationary in terms of, it's not stationary in terms of mean, variance. Kasi may fanning out siya, lumalaki siya across time. Okay? Alright, so this is stationary in mean and variance. This is not stationary in mean, not stationary in variance. And then meron pa ditong time-independent covariance, which is really not our concern. Ang mas concern natin ito at saka ito. Okay, any questions? Kunin ko nga yung lagay ko lang dito para okay, thank you. Konti lang nag-feedback, ha? I hope the others will also give their feedback. Okay. So, importanteng stationary time series natin, no? Kasi class, sabi natin, a stationary time series is one whose physical properties, such as mean, variance, autocorrelation, are all constant over time. Okay? It has the property that the mean, variance, and autocorrelation structure do not change over time. Kasi kung ganun siya, class, then sabi natin, then we can model this using Arima, yung Box-Jenkins approach. Otherwise, if it violates this, then hindi siya pa pwedeng gamitan natin ng Arima. Alright, so ito yung steps that we need to perform. So number 1, check na muna natin kung stationary. Okay, kung hindi siya stationary, kunyari, ano siya, may trend siya. So it's not stationary in mean. There's some modification that we can do. No? We can difference the data. Kasi pag dinifference natin data, pwedeng matanggal yung yung non-constant mean. Okay? So pwede natin i-difference. Ngayon naman kung hindi siya stationary invariance, what you can do is to do log transform. Ibig sabihin, get the log of the data. Okay, so these are what we call transformations that we can do in order to convert our data into a stationary time series. Okay? Ngayon, pag pareho naman silang may trend at saka may non-constant variance, pwede nating i-combine, no? Okay, first get the difference of the log transformation. Okay, so ang unang gagawin natin diyan, kukunin natin log tapos kukunin natin difference. And usually hindi pwedeng mauuna muna yung difference tapos saka yung log. Kasi pag kinuha natin difference, pwede magkaroon ng negative values yan. Pag may negative values na siya, hindi na natin pwedeng kunin yung log nun. Okay, unless we do another transformation. So what usually happens, get the log first, and then get the difference. And then when you have this clash, that means that you're now working with the different data na, no? Kasi difference sa data na to. Ito yung tinatawag natin yung Arima PDQ. Naka-difference na yung data natin. It's no longer the original data. And of course, after you model that, pwede naman natin i-revert back to the original data. Okay? Okay, and once you have done the transformation, check natin. We can do statistical test kung stationary yung data na natin, no? We will do that. And then to help now determine yung model natin. Kasi kunyari na determine na natin na statistically we were able to show na stationary yung data natin. So now we can come up with an autocorrelation function and an partial autocorrelation function to determine kung anong model siya. Anong Arima model ba yan? Is it an Arima 1111? Is it an Arima 31? An Arima 13? Etc. So after we are able to convert it into a stationary data series, and that's the time na pwede tayong mag-create ng model ng Arima. Kasi as I said, hindi tayo pwedeng mag-create ng Arima model kung if our data is not stationary. Okay? Then after that, okay, we will now determine kung ano yung pinakamagandang Arima model. Okay? So kunyari, stationary na yung data natin. Stationary na siya. Then we now create a model for that and try to find what's the best Arima model. Kasi maraming iba't ibang model, di ba? Pwedeng Arima 11, pwedeng Arima 21, Arima 51, etc. So you know the definition of Arima 51, di ba? Okay. It's okay, Lawrence, no? So we know that class, no? So after we identify the best fit Arima model, we can now forecast. Okay? So once we have identified the best model, we can now forecast. And then yung model natin, i-check din natin ulit. No? Just like any regression, yung residuals natin, we will have to check yung residuals if okay na yung okay yung model natin. So that in a nutshell, class, is how we construct a model, an Arima model for our time series. Okay? So sabi nga natin dito, class, a stationary time series looks like a flat-looking series. Walang trend, yung variance siya constant over time. It's a constant autocorrelation structure over time and no periodic fluctuations. Okay? So, in other words, a stationary time series is one whose properties do not depend on time. So hindi function ng time. Walang trend kasi ang trend function of time yan eh. Walang non-constant variance. Lumalaki yung variance across time. So function din ng time yan. Okay? So I hope that's clear, class. We can only model if the nalagay ko pala to, no? Na doble. Sorry. If the data is stationary. Okay. Pag stationary yung data, class, another name for that is ito. White noise, no? Okay. White noise, no? So white noise series is stationary. It does not matter when you observe it. It should look much the same way at any point in time. In general, a stationary time series will have no predictable patterns in the long run. Time plots will show the series to be roughly horizontal, although some cyclical behavior is possible with constant variance. So no trend, no variance is constant across time. Okay. All right. So sabi natin, class. Okay. Pag stationary na yung data series natin, okay, we can now use the Box-Jenkins approach. Box-Jenkins consists of your Arima in order to model. A stationarized series is relatively easy to predict. That's the reason, class, kung bakit natin kailangan gawing stationary yung data through the use of mathematical transformations. As I said a while ago, if our data is not stationary, kunyari may trend siya, anong gagawin natin pag may trend? You can get the difference. Pag kinuha mo yung difference yan, usually nawawala yung trend. Or non-constant yung variance by fanning out. Across time lumalaki yung variance niya. So anong pwede natin gawin? Kunin yung log. Okay, get the logarithm of that time series. Pag kinuha yung logarithm ng time series, usually na-address yung non-constant yung variance. If it's a combination, kung meron trend at saka merong non-constant variance, anong gagawin? Combination dapat. Ano mauuna? Yung differencing or yung getting of the log? Ang mauuna muna yung getting the log. Okay? Why? Why do you need to get the log first before you get the difference? Kasi pag nag-difference ka, possibly, there's a strong possibility that you'll have negative values. And then pag nag-negative values ka na, hindi ka na pwede mag-log kasi the log of a negative number is non-existent. Hindi ka pwede mag-log ng negative. That's why ang inuuna, maglo-log muna tayo. Kung hindi pa rin ma-address yung logarithm, kasi yung log, it will not address the malamang, hindi niya ma-address yung trend, no? Yung going up or going down. So what we do is get the log first and then get the difference. So in that way, we address both the non-stationary mean and the non-stationary variance. Now, kapag nag-difference na tayo, class, then you're in effect doing an Arima model na. Kasi integration dito means differencing. Okay? So, ang imo-model natin, Arima na, kasi yung I dito stands for integrated. Integrated means nag-difference tayo. Okay, so let's now go here, class. Gagamitin na natin si Apple para mag-ano tayo. So let's get the Apple stock prices. Gawin na lang natin tong 2022, no? So kunin natin yung 2022 time series. Okay? All right. So in order to save on time, ang ginawa ko, class, binigay ko na yung code sa inyo, no? Ng most of this, which actually I don't like kasi gusto kong kayo yung nagsusulat, no? But because we're pressed for time, okay, so in this exercise, I'm going to do it here. So you know what to do, di ba? Get symbols, okay, Apple, and then isa subset lang natin from 2004 or 2014 up to 2022. Okay? Okay, ang maganda rin dito, class, na pwede rin natin ilagay start date. Sometimes it's better to do this para naka-identify yung start date natin. So ang start date natin is 2014 01 01, and then end date natin. Ang advantage ito, class, you can make use of this variable. And then you can change this one, yung start date, end date, automatically lahat ng start date and date magbabago din. So that's the advantage of using variables like this. 12/31. Okay. So from 2014 to 2022, yun ang ano natin, target na data natin. So from is start underscore date. 2 is end underscore date. Then i-complete lang natin para ano, ang source natin src is equal to Yahoo. And then pwede na natin gawin ano to, no? Pwede yung auto.assign, di ba? Auto.assign. If we want to give it a name, then ilagay natin yung name dito. Kunyari AAPL. Okay, so let's do that. AAPL, small letters. And then auto.assign is equal to 2. Okay, which means that ayaw natin gamitin ni R yung AAPL na to name it. We want R to use AAPL. And then, so this will be AAPL small letters na. Okay, so let's run this. Run. So we now have here our AAPL. Saan na AAPL natin? Hindi pa tapos. So nag-create tayo ng AAPL, no? Na object. Mabagal kasi internet ko, no? So medyo nag-ano siya. Were you able to get it already, class? While this is running, so hindi na kailangan to, no? Nasama ko na siya sa view. I'll just delete this. Taking so long. Nag-run na sa inyo, class? Paki-chat naman, please. Tagal, ah. Sabi dito, terminate? No, I don't want to terminate it. Medyo nagkaroon ng problem siguro sa connection ko. Let me rerun it. Okay, that should not take a long time. Unless na talagang may problema yung internet connection ko. How about in your case, class? Nag-load na? Yeah, thank you, Kuji. How about the others? Ayan, nag-load na rin sa akin. Yan yung Apple. Okay? So, all right. Bakit mali, no? Bakit yung Apple ko ay kasi mali yung code ko, no? Sorry. Ang code ko, class, dapat auto.assign should be false dapat to, no? Sorry. Ginawa kong true. Kaya ang ginawa ni R, inassign niya kay Apple kasi auto.assign. Tapos si Apple ngayon naging parang character variable lang, character vector. So let me rerun this. Okay? So ngayon, AAPL na yung magiging object natin. Kasi auto.assign is equal to false. Sabi ko, create this object AAPL. Ang problem ko lang, ang bagal ng internet ko. Okay, so you should have been able to run that. Hindi po sa akin tapos. Hindi pa napapalitan to. So it's taking quite some time, right? So sige, if you're done already, what do you get in structure class? Ano structure si Apple? What structure? Okay, yan na. Okay, dyan na si Apple ko, no? Alright, so I got already Apple. Okay, thank you, Kuji, you're correct, no? So if I get the structure of Apple, the AAPL, small AAPL, okay? So XTS object yan. Ano ibig sabihin XTS object? Extensible time series. Okay? So what's the difference between an extensible time series and an ordinary data frame? Sabi natin, index. No? Okay, you can see here the index. It consists of the dates. Ito yung index niya. And then if we get our data from Yahoo, the stock prices, you have OHLC, open, high, low, close, the volume, and then the adjusted. Okay. And the class, i-run ko nga to lahat. So XTS object siya. And then the class, of course, is ito, no? XTS or zoo. And then the first 6 heads siya. The first 6 observations. 2014, January 2, hanggang January 9. So those are the first 6 observations. Head Apple. Okay, so remember, ang gagawin natin dito, imo-model natin. No? So let's just use the adjusted closing price. Okay, we have the option to use the closing or the adjusted closing. Ang maganda sa adjusted, it adjusts for stock splits, dividends, etc. No? So let's create this object AAPL. We will overwrite yung AAPL natin. So it will only be, di ba, ito brackets, it will only be the 6th column of AAPL. Okay, so let's run this. And you can now see that this is now our Apple object AAPL. Isa na lang, no? Yung Apple that adjusted. Okay, and then let's change, no? Let's use the column names function. Column names ang Apple. Okay, since isang column lang naman yan, then we can write here. Actually, you don't need C here, no? Okay, iisa lang naman yan, no? Column name si Apple, so let's replace it into ADJ adjusted. Yan natin. Okay, siya. ADJ na. No? That one. Kanina kasi, ano yan eh, Apple that adjusted, so mahaba. Okay, pause muna ako, class. Any questions so far? Klaro ba tayo? Paki-chat naman please kung clear. Lilima na lang tayo. Okay, thank you. Okay, good. Yung iba, kamusta? Okay, Kim, thank you. Kuji, thank you. Hana, thank you. All right. Okay, so we have just a few more minutes na lang. So kunin lang natin tong iba para at least matapos natin hanggang dito, no? Okay, so we can plot the prices. So I'm going to create this object called P1, and then I'm using the autoplot function. Okay, autoplot AAPL plus, and then I'm going to give it a title, grammar of graphics title, Apple closing prices from January 1, 2014 to December 31. So this should be 2022, no? December 31, 2022. And then yung label natin, yung Y natin, yung Y-axis natin, gawin natin daily prices. Okay? And then we have P1, daily lang klase. Okay, sorry about that. I-run ko lang to and then let's call it a day kasi time na. No? So if I run this, what happened? May object na P1 na generate yan. It's a plot, no? So ang laman ng P1 na yan, okay, so may data siya, may scales. This is a ggplot object, no? So it's used for plotting. It's used for charting, no? And then we use ggplotly. Okay, explain ko na yung ggplotly next time. Okay, so this is the plot for our Apple series. Yan. No? And then here, tingnan natin to. Hindi nag-print yung plotly. Okay. Ito si plotly class, no? What's this? Interactive plot to, yung plotly. No? If you take a look at this, for example, yan. Pwedeng i-auto-scale ko siya. Kunyari, ang gusto ko lang yung portion dito, no? I can auto-scale this. I can just highlight this. Tapos yan lang yung ipapakita, no? So, we'll continue with this next meeting. Tingnan nyo lang tong class, no? This is a very powerful, yung ggplotly. Maraming pwede nating makita dito, no? All right, so let me end there, class. Okay, and I'll see you next meeting. So we'll continue with this next meeting. Itong another way to plot. Okay, and then we will go to, ito na tayo, no? Kung stationary ba siya o hindi. We will answer that kasi kailangan natin malaman kung stationary siya. Kasi ang next step natin ngayon, i-model natin siya using Arima. Okay? So thank you so much. Did you learn something today? Kahit pa paano ba may natutunan? Class? Pa-feedback naman kung okay. Thank you, Kim. Okay. So good. So ma-reinforce yung natin yung knowledge natin about Arima. Okay, with that, I stop recording now.